Hello dear student, I am Mondu Islam. Today in this video we are going to discuss an important question of NBHM 2022. Okay, this question from NBHM PHD 2022. So this question from real analysis and we are going to discuss this. Okay, previous video we have discussed on question from real analysis and it is the same question that asked in NBHM PHD exam. Okay, so let's start. This is a very nice question. Okay, this is a question. The question is that script C be a subset of all real valued quantum function fx on minus 1 on R. Okay, it is a set of all real valued quantum function. Okay, I am writing its meaning. F is minus 1 such that f is greater than equal to 0, f is non-negative function for x goes to minus 1. What does it say? It says that script C, okay, script C is nothing but the set of all function. Those functions belong to set. Those are from minus 1 to, those are defined from minus 1 close interval, and it is real valued, means f is mapping from close minus 1 close interval to R. Okay, and also further, if it is a real valued function means value will be real. Each value have real, means each x belongs to minus 1, you get fx will be a real number. Okay, and moreover it says that f will be a quantum function, so such that f is continuous. Okay, those functions belong to this script C, such that this real valued quantum function from minus 1 to R, minus 1 close to R, so it is continuous also. Continuous on minus 1 on domain. Okay, so f is continuous on minus 1. Moreover, also f is non-negative. Also one more condition given, then f is non-negative. Okay, for equals to minus 1 for 1. Also one more condition given, that is, this is a very important question, very important condition. Limit sub n is infinity minus 1 to 1 f is equal to n dx will be less than infinite. Okay, this is a very important condition. Limit sub n to infinity minus 1 to 1 fx whole power n equal to n dx. This will be finite. This integral should be finite. Okay, limit of this integral should be finite. Okay, this is script C. So script C is the set of all function from close interval minus 1 to R. Okay, and such that f is continuous on minus 1 and f is non-negative, and also this condition is specified. Integral under minus 1 to 1 f is whole to n dx, its limits will be finite. Okay, so it asking what is the image of C, what is the image of C in R under the map that take effects in this integral. Okay, means it asking that what is the image. Suppose phi be the map, that map sending f to minus 1 to fx. Okay, dx. This is the pre-image and this is the image under the map phi. Okay, phi is mapping that sending f to minus 1 integral fs dx. Okay, so it asking what is image of phi, means image of script C under phi, means it asking what is this set, or you can say image of script C under the map phi. Okay, this is a question. Okay, hope you understand this question. This this the question says. Okay, now I will write the question solution. Okay, so we have to determine this, what is phi of script C. Okay, we will find what is phi of script or image of script C under the map phi. Okay, these are question. See, suppose I am taking an arbitrary f. I am taking an arbitrary, let a belongs to script C be arbitrary. Okay, I am taking arbitrary f from script C. Then it satisfies the condition. Okay, that f will be continuous and it is non-negative, and also this integral will be finite. Okay, so then we have you can write f is continuous on minus 1 on this integral. Okay, also f is non-negative for x belongs to minus 1 comma 1. Okay, and also this integral limit sub n tends to infinity minus 1 to 1 fx whole power n dx. Okay, this will be finite. Okay, you can name it 1. This condition is very important, so I am naming it 1. Okay, otherwise this condition you cannot solve this problem. So now, say it given that fs is non-negative. Okay, it is given fs is non-negative. So my claim is that I am claiming on thing that my claim is that I am claim that mod fx will be less than equal to 1 for all x belongs to -1, in the above condition. In the above condition, this condition, I can say mod fx will be less than equal to 1 for all x belongs to -1, okay. So we have to verify this claim. Okay, we are going to verify this claim. So suppose if possible let mod fx equal to, suppose a real mod fx will be a real number. Okay, because fs is real valued, this function is a real valued, means this will be a real number. Fs is a real number, so modulus of this f will be also a real number, so I name it a. Okay, since we are going to method of contradiction, so I am assuming it on contradictory it will be greater than 1. Okay, but x belongs to -1, close interval. Okay, so I am assuming mod f is equal to a, be a real number which is greater than 1. Okay, which is greater than 1 for x belongs to -1. Now since f is non-negative, if it's a non-negative function, okay, non-negative, so its modulus will be itself. Okay, non-negative function, according to the definition of modulus, you can say if it is non-negative, so its modulus will be itself fx. Okay, so you can say it will be greater than 1 where x belongs to -1, 1. Okay, now we can take fx power n on both sides. It is integer power. Okay, so it is greater than 1 means greater 0. You can take integer power, so I am taking integer power in both sides. If you take integer power, fx whole to n will be h to n, but x belongs to -1, 1. Okay, now for n be an integer, you can say positive integer or natural number. Okay, now I am integrating it from -1 to 1. Since f is constant function, it is given f is constant function. Okay, it is given f is continuous. Here written f is continuous. We know every constant function is Riemann integral. Since it is continuous, then every constant function is Riemann integral, so you can integrate it. Okay, from -1 to 1. I am integrating it -1 to 1 dx. So h1 will be a constant. So it integrate if you integrate this on -1 to 1, so it gives -1 to 1 dx. Okay, now I am taking, so this will be integrate s will be, this gives 2 h to 1n. Okay, for it will be true for all n greater than 1 and for n greater than 1. Okay, now take limit sub of this, limit sub of this n tends to infinity. Okay, -1 to 1 fx whole power n dx. This gives will be limit sub n tends to infinity to h to 1n. Okay, now 2 will be constant. Okay, since 2 is constant, so you can take it outside, so it gives limit sub h to 1n into infinity. Now we know that this limit n tends to infinity h to 1n. Okay, this will be infinite if a greater than 1. Okay, it is very much trivial. You can put a equal to, if you have any problem, you can put here a equal to 2. Put a equal to 2, so this gives 2 to 1n, and 2 to 1 limit infinite, we all know. Okay, so limit h to 1 is infinite when a greater than 1. So since the limit exists, we know if limit exists, then it will be equal to, since it limit exists, it is infinite but it exists, so it will be, this limit will be equal nothing but equal to limit sub h to 1n n tends to infinity, and this limit will equal to limit inf. Okay, if limit exists, we know no limit, limit sub equal to limit equal to limit sub equal to limit inf equal to limit. If the limit is exists, then we can say these three things are equal. Limit sub equal to limit inf equal to limit. Okay, so I can say limit sub equal to limit, so this will be infinity. So since limit sub h to 1n is infinity, this will be, in this case, become infinity. So 2 into infinity, this gives infinity. So you can set this integral, therefore this integral limit n tends to infinity sub -1 to 1 fx dx, this will be infinity. Okay, this will be infinity, but this is gives a contraction. Okay, I prove if f is less than, if is greater than 1, I prove if f is modulus of f is greater than 1, then from here you can conclude then that this integral limits of this integral will be infinite. Okay, this integral will be infinite, but it is a contraction because it is given it is less than finite. This integral is finite. From 1 it is contracting. It is given from in 1 the limits of this integral will be finite. Okay, but I have proved that it is infinite. So if it is infinite, then it is infinite, it is infinite. So this is a contraction. Okay, so 1 and 2 gives contraction. From here you can name it 2. So 1 contradict 2. Okay, so this gives a contraction 1 contradict 2. From here, so from here you can say that mod fx with never less than 1. We can say mod fx. I have claimed that mod fx greater than 1, so it is not possible because it giving a contraction. This integral is finite, but this integral will be infinite if mod fx greater than 1. Okay, so you can say the modulus of fx is not greater than 1, means it will be less than equal to 1. So you can say from here that my conclusion is that conclusion, what is my conclusion? So you can say modulus of fx, this will be less than equal to 1 for all x belongs to -1, 1. Now now see from here you can write that we all know f is non-negative, is given. So if it's non-negative, f can be always made less than mod fx. Okay, mod fx will be less than 1 from above. So you can say for this will be hold for x belongs to -1, 1 percent. Okay, now if this is continuous function, this given it is continuous function. Okay, continuous on -1, 1. Okay, now we know every continuous function is Riemann integral. Since we know every continuous function is Riemann integral, every continuous function is Riemann integral. Okay, so it will be Riemann integral on -1, 1. It will remain integral on -1, 1. Okay, so you can integrate this, thing. Okay, since f is continuous, so it is Riemann integral, so you can integrate this from -1 to 1. So if you integrate this from -1 to 1, so this gives -1 to 1 0 dx less than -1 to 1 fx dx. Okay, so this gives -1 to 1 1 dx. Okay, now so this gives 0, integral of 0 will be itself 0, -1 to 1 fx dx, and this is my integral of dx from -1 to 1, so this gives 2. Okay, so you can say here, you can say 0 less than integral of -1 to 1 fx dx less than equal to 2. Okay, so I've taken an arbitrary f from image of phi. Okay, see, I have taken an arbitrary f. Previously I have taken, you have to take image of phi. I have taken arbitrary f from, you can say, image of phi, from phi psi. Okay, if you take arbitrary f from phi psi, then it's showing that image -1 to integral f dx is nothing but the image. Okay, it is the image of f. Okay, because f is the, because phi is the mapping, since phi is the mapping, that map f to the is f map to -1 to 1 f dx. Okay, so you can say from here image of phi, image of f will be -1 to 1 f dx. Okay, so phi f will be lies between 0 to 2, closing 0 to 2. Okay, so phi is lies between 0 and 2. If you take arbitrary f from phi f, means image of f. Okay, so you can say from here that if you take arbitrary f from phi of f, means image of phi, then it lies on the closing interval 0 to 2. So from here you can say, since f is arbitrary, since f is belongs to phi f, phi square c is arbitrary. It is arbitrary. You can say it was, since phi it is arbitrary, so you can say 0 less than phi of square c. This will be for lies on close 0 to. Okay, so you can say range of this set square c will be close 0 to. Okay,
means since from here you can since we know that this phi of f will be always less than 0 to 2 for any f belongs to image of script C. Okay, so from here you can easily tell script phi of image of C is nothing but a closed interval 0 to 0 close than 0,2. Okay, and it is nothing but image of script C under the map phi. Is nothing but phi of script C means phi of script C means it is image of script C under the map phi. Okay, so you can say phi script psi, or it is nothing but image of script C under the map phi. This will be close interval 0 to 2. Okay, and this is our answer. Okay, we will determine this question. It is asking that image of phi image of phi, or image of sqc under the map phi. Okay, image of sqc in R under the map that takes -1 to dx. Or I have taken the map f to phi, so I have to determine so I have determined phi of sqc. So I have determined phi of sqc. Phi of sqc is nothing but a close interval 0,2. Okay, so hope you understand this solution. Okay, if you have any problem, you can always ask in the comment section. Okay, if you have any problem regarding to this solution, you can always ask in the comment section. In upcoming videos, I will discuss more solution of NBHM PHD. Okay, after that I will upload lecture videos and also CSIRNET problem. Okay, so please subscribe my channel and follow my channel. Okay, hope this channel will give you more solution and more update regularly. Okay, so this is a nice question, and this question for real analysis. Okay, hope you understand this solution. If you have any doubt, you can always ask in the comment section. Okay, so answer is this, close 0 to. Okay, in official answer key it was mentioned that answer is close 0 to. See here, close 0 to is the answer. Close 0. The answer will be close 0 to. Okay, so thank you, and thanks for watching, and I'll upload more video in upcoming videos. Okay, so thank you.